Okay, so, all right, so again, that's our goal. So our goal is, again, for you to understand sequences and to describe a recursive sequence and the terms. So you are going to look at a list of numbers. You are going to decide how is the sequence moving, and then you will, using that same rule, derive some more terms along that sequence. The standards are there because as math teachers, all math teachers across the country use the same set of guidelines. So these are the guidelines that every teacher who is every math teacher who is teaching sequences and functions will use. Okay, so you are going to write a function that describes the relationship between two quantities. So again, you've been doing it all along. You are just finding the rule. Okay, and then the second part just breaks it down further. Okay, so determine an explicit expression, and explicit, just a direct expression, the process for calculating the next terms. So here's our agenda. We just had community meeting. We are going to do a review of the pre-assessment that you all took, and we are going to talk about types of sequences, and then we are going to close. So we're going to use my screen down. All right, so, here we are. All right, so the other day, I asked you all to look at the pre-assessment. Okay, and again, I said that, oh, excuse me, the pre-assessment is for me to see what you remember about where we're going. So in the first one, fill in the blanks to continue the patterns. 3, 6, 9. Do you remember, either one of you? You remember what you put next? Okay. All right, so number 1 is what we are going to be studying first. There is a rule that guides each of them. We are going to talk about that rule. You know, you started with 6. I mean, you started with 3. Now you have 6. Or excuse me, you started with 3, then you had 6, and now you have 9. Okay? So again, what is the pattern? What is happening? And it has to be the same operation as you move from the first term to the second term to the third term, and derive the other 2 terms. Okay, so that's what you had to do in number 1, and that's where we're going to begin. And you see in the first 2, they are increasing. The first 3 are increasing, but D is decreasing. So, do either one of you, or would either one of you like to contribute your answers? It's only the 3 of us. Anybody? Okay, that's all right. Because
Is the first one times 3?
Is it times 3?
It's multiplied by 3.
What's multiplied by 3? 3 times 3 gonna give you 6. Think about it. What operation?
That's okay. Hold on. Give me a second.
Yeah, because 3 times 3 would have gave us 9 as the second term. So not times, but
It's addition.
absolutely. Yep. So add 3. Yes. All right. So the next 2 terms.
Is it times 2?
Yes. The Yes, for B, yes, times 2. Talk to me, ladies. All right, what somebody do with C? Same concept. Don't let the presentation bother you. Instead of having the first 3, you have the middle 2. That's all right. What about D? We don't have to do with stuff in order. We don't have to talk about it in order. What's happening in C or D? Whichever one you get.
Divided by 2.
Yes. Yep. D, yep. We dividing by 2. And if you keep it moving, yes, you will get 18. So what happened to C? Same thought process, ladies. Instead of them giving you the beginning, they gave you the middle.
The 1 and the 9 is messing with me.
But check it out though. It's a number between 1 and 9. So do 9, 13, and then work backwards. Yeah, find that pattern in the middle, and then go backwards from 9, and then you will go forward from 13. Cool. What's the difference between 9 and 13, ladies?
4.
Absolutely. So now you will go forward. So now you added 4 moving to your right. So subtract 4 and you get 5 here. Will it work? So from 1 plus 4 is 5. It'll work. And then on the back side, just add 4. But yeah, don't worry about the presentation, ladies, because y'all probably overthought that. Like, it's this the trick bag. Nope. Same concept. They just gave you the 2 terms in the middle. So we're going to talk about that first, and we're going to start that today in our discussion. We're going to work on patterns, because from patterns, we are then going to move to writing it in function notation. So this might take you back to algebra 2, because remember, as applied math, this is your math elective. So you have the 3 major maths, and then you have to take an advanced math. So 2 takes you back to graphing. So if you like the graph, then number 2 is going to be right up your alley. Okay? So we do patterns first, patterns and sequences, and then we're going to move to functions. So that's what they expected here. And they wanted to test to see if you understood not only the notation, but then how to apply it to the function. Okay, so that's what 2 was about. So again, if you didn't remember, it is okay. This is, again, the pre-assessment, because I just want to see what you remember. Now, number 3 is the word problem. I wasn't too concerned about part B. I was concerned about part A, because That helps me understand if you understand how to break down a word problem. Okay, so a city bus charges 25 cents per ride. Excuse me. If you first buy the 10, oh, that must be $10 discount card. Let B be the total cost in dollars of taking in rides on the bus. So okay, so they're telling us before we take any rides, it just cost us $10 because we bought the card. And then they wanted you to determine how much would have been spent if you take 2 rides, 4 rides, 10 rides. Okay, so again, depending on your understanding of the word problem, tell me, either one of you, if you took 2 rides, what would be the total cost? Because that's going to let me know if you understand.
20.
Wait a minute. Remember, a city bus charges 25
I wasn't
cents.
even looking at the problem.
Oh, okay, that's all right. That look, and that's why we going over it, girl. So, yep, a city bus charges 25 cents per ride if you first buy the $10 discount card. So 0 rides, it just cost you $10. You ain't get on the bus yet, but you got the discount card. So how much will you have spent if you take 2 rides?
Is it gonna be 10.25?
That's only 1 ride.
Okay. 10.50?
All day. Yep. Because you had to buy the card, so the $10 is there off the top. And then they said 25 cents a ride. Exactly. Yes. Yes. And that's what number 3 was testing. Number 3 was testing, can you break down a word problem and then apply it in the, you are applying it in filling out the table. And I like word problems, and I will give you 1 or 2, okay? Because life is a word problem. Okay, you just hear it instead of seeing it on paper. When you go in stores and all that kind of stuff, you doing word problems like a mug. You know what I mean? Since you were a kid, you went in the store, you had $1 or you had $5. You bargained it out. All right, the soda gonna cost me $1. You doing the word problem, you working it in your head because you making sure that when you get to the counter, you're gonna have enough to get all the stuff that you want. You've been doing word problems, you just don't see them on paper. Okay, so I'm not too worried about the sketching because I hope to get to show you all how to do it on the computer. Now, number 4. Number 4 was testing to see if you understand exponents. So in number 4, you were supposed to select all the expressions that are equivalent to 2 times 2 times 2 times 2 times 2 times 2. And remember, when they say all, that means that there is a possibility that there is more than one answer. Okay? And again, we'll use exponents in one of the in discussing, one of the sequences. So, how'd you all feel about these, ladies? Was it comfortable? Was it uncomfortable?
I'm okay with the exponents. I just need like a pen and paper to do it.
Okay, all right. So I see.
Like I know A is equivalent, but I gotta go through the other ones.
Right. Yep. A is equivalent. I agree. 1, 2, 3, 4, 5, 6. Okay, so I maybe
I think it's just A. No.
Nope. It should be. It's 4 of them. So I agree with A. So now, do you see anything now? See, because here's where your rules of exponents come in, right? So now, 2 to the 6, I agree. 2 is the base. 1, 2. You got all 2s and you have 6 of them. I agree. Do any of these other possible expressions get you to 2 raised to the 6th power? So 2 times 6 is 12. So we know that's out. What about this one?
2 to the second power is 4. And then 4 times, which you multiply by 2 again, right?
No. Because if you got 4 inside, now you're going to do 4 times 4 times 4. Because you simplified inside and got 4. So now you're going to have 4 to the 3rd power.
That's 64.
All day. So that's one of them. Yep. A, C. What else? Because I can't write on it either. Let me see, right now. Yep. So we got A, which is apparent, straight up. 2 is the base. We have it 6 times and we multiplying. Here, same thing. She followed order operation. So first inside, that she did parentheses and then exponents. So yep, C. What else? There's 2 more in there.
Is it G too?
Yes. Yep. G and one more. So for letter C, right? When you raise a power 2 to another power 3, you keep the base and multiply the exponents. So 2 times 3 is 6. You get back 2 to the 6. In G, when you are multiplying with exponents, you keep the base and add the exponents. 2 raised to the 3 plus 3 gives you back 2 to the 6. Okay, so that's what 4 was testing. So what's the last one? I told you it was 4. So we said A, C, G, and what else? H. You taking a power 3 and raising it to a power 2. Keep the base, multiply the exponents. So H and C are opposites. You see it's 2 squared raised to the 3rd power, and then down here you have 2 cubed raised to the 2nd power. But yep. So again, we're going to be using exponents. So 4 was just testing to see if you could recognize this expansion in its exponential forms. And then lastly, for number 5, again, it's back to patterns. So again, like I said, that's where we're going to start. We're going to start with patterns. So they gave you 3 patterns with the first 5 terms. And again, you are looking for the rule. This is similar to when you were in middle school, when you had to do in and out tables. This is in and out tables on the next level. Good morning. How are you? Hey, Miss Cows. I was getting ready going to my spiel. But yeah, so for 5, again, we started with 5. We did something and got 8. We did that same thing, got 11. Did the same thing, got 14. Did the same thing and got 17. The question is, what did we do?
Add 3.
Add 3. Yep. So look at B. We started with a half. We did something and we got 1. We did that same thing and now we got 2. We did that same thing. We got 4. We did that same thing again and got 8. What did we do?
Multiply by 2.
Oh, dang. Look what y'all doing. And what about C? 0. You had 0. You started with nothing. You did something, you got 1. You did that same thing and got 3. You did that same thing and got 6. You did that same thing and got 10. Is there, can you think of something that you could have done that would have gotten you that result? Is there anything? So what that shows is there may not always be a pattern. There is a pattern, but it is not one consistent operation because we can produce this. But we started with 0. We added 1 and got 1. Then we added 2 to 1 and got 3. Then we added 3 to 3 and got 6. Then we added 4 to 6 and got 10. So there is a pattern, but not the type of pattern that is recursive, recurring, happening over and over and over again. There is something different happening in pattern C. So that was what they were kind of going at there. So don't overthink it. I don't want you to burn your brain. Okay? And again, like I said in number 6, I'm not too concerned about us graphing because we will, if we graph, I will discuss the graph with you and I'll plot the points as you all discuss them with me on my Google board right here. Okay. So, well, that was cool. So our review happened. We are now going to, I'm gonna stop my share. So we are going to, on Thursday, we're going to move into the lesson, okay? And again, we are going to start with patterns. We are going to start talking about sequences and the 2 different sequences that may occur. Okay, so my loves, I thank you. It was a meeting in the ladies' room today, but I appreciate you both for coming. Thank you so much, and I will see you on Thursday. Thank you, darlings.
Bye.
See you,
Bye.
baby.